know how to tell the time? Do you ever think about maths involved in knowing how to tell the time? Well, whenever you look at an analog wall clock, you see the numbers 1 to 12, but somehow you automatically convert it to minutes using the numbers that you see. You automatically realise that if the minute hand is on the number 1, you say 5 minutes, not 1 minute. And there's no number 60 on the clock either, yet you know that when the hand has rotated around the clock once, it has moved 60 times, which means that somehow you've realised that the number 12 has a connection to 60 seconds or 60 minutes. Are you even aware that you're using factors and multiples to do this? How you divide the time into smaller units. How amazing is that? There are so many other applications for using factors and multiples in our daily lives, including, for example, money. Have you ever handled money in your life? Of course you have. Buying and selling, of course. When you make a decision to use 2 10-pence pieces instead of a 20-pence piece, or a cent, or a nickel, or a dime, or a quarter instead of a dollar. Oh, that American accent is so bad. You've exercised your knowledge in factors and multiples. What about those who are into music? Bobbing your heads. So when you tap your feet or fingers or bop your head up and down to the music, it's your brain making sense of the sound. It's basically the pulse of the music, and it's called backbeat. And you essentially have different beats within the measure, based on multiples of 2, 3 and 4, continuously repeated over and over. For example, a popular tempo of pop music is 120 beats per minute, which is multiples of 2 and 3. Drummers use backbeats from 2 and 4. And what about baking? So you want to make some gingerbread biscuits, but the recipe only allows you to make 12 biscuits, and you need 36. So you have to triple the entire recipe in order to make your 36 biscuits. And once again, this is factors and multiples at play here. And what about in technology, when you choose to buy a device with specific dimensions, such as the aspect ratio of the computer screen or the resolution of a display? You are meddling in the subconscious world of factors and multiples. So let me formally introduce you to Mr. and Mrs. Factors and Multiples. But what's the difference between factors and multiples? We already touched on factors in my other video on prime numbers, so check that out when you've got the time. But I'll explain it here again briefly. Every number except 1 has at least 2 factors, 1 and itself. And if they only have 2 factors, they're called prime numbers. And if they have more than 2 factors, they're called composite numbers. It's a bit like knowing the difference between vowels and consonants in the English alphabet, where vowels are basically A, E, I, O and U, and consonants are the remaining letters. And what's the difference between these? Well, 2, 3, 5, 7 and 11 are prime numbers, and all the other numbers would be the composite numbers. So when we look at the first set, 2, 3, 5, 7, 11, these are the prime numbers, and they have only 2 factors, whereas the composite numbers 4, 6, 8, 9, 10 and so on, they have 3 or more factors. Let's take a look at factors first of all. A factor is the number that's divided into another number evenly without leaving a remainder. You can imagine factors like they tell you the facts about the number. And the multiple is when you repeatedly multiply those facts to get a different number. Or the reverse of it is that this number can be divided evenly by another number, namely its factor. So you can think of factors as the building blocks of a number, while multiples are the results of multiplying the building blocks. Let's take the number 6, for example. We'll start by looking at the building blocks that make 6. So you can have one big block of 6. That's like 1 times 6. Or you could have 6 individual 1 blocks. So that would be 6 lots of 1. And again, you still make 6 this way. Or you could have 2 blocks of 3, which again would give you 6. And lastly, 3 blocks of 2, which will give you 6. So here you can see 6 is a factor, 1 is a factor, 3 is a factor, and 2 is a factor of 6. So here are our different blocks, And we can put them into a stack to show you that they represent 6. And this here shows you the factors of 6. But now, for the multiple part of this marriage, let's have a look at how we can build on these blocks to make a stacking wall. So these different blocks of 6 show you the factor 6. So if we were to draw a line over this point here, you could think of this as like roots of a tree. What makes 6? So these down here are your factors. 1, 6, 3 and 2. Now everything above the line is going to be your multiples. So let's take, for example, another number. The number 12. 12 is a multiple of 6. If we add another block, here you can see 2 blocks of 6 give you 12. And also, if you wanted to take another number like 18, 18 is also a multiple of 6, as you can see by adding another block. So now we have 3 blocks, all making 18. So the factors of 6 are 1 and 6. Leave a gap in the middle.
Mind the gap.
And then you would write 2 and 3. So here, 1 times 6 is 6, and 2 times 3 is 6. And there's no other numbers between 2 and 3, so we know we've located all its factors. Now, what about multiples? And we're looking at multiplying 6 out. So the first multiple of 6 will be 6 itself, and then after that it will be 12, and then 18, and then 24, and so on. And it will keep going up until infinity in blocks of 6. And those are your multiples. Okay, so now I just want to run you through the process of actually how we find the multiples and factors. So we'll take this example here, number 35. We'll start off with multiples this time. So with multiples, all we're doing is adding 35 on top of each other like a stack. So the first number, the first multiple of 35 is actually 35. Now we're going to add another 35 to that. So 35 plus 35, so 30 plus 30 is 60, 5 plus 5 is 10, 60 plus 10 is 70. And then we had another 35, so 70 plus 30 is 100, plus 5, 105. And then 105 plus 35, add 30 to 100, you get 130. 5 plus 5 is 10, so it's 140. And then one more, 140 plus 35, 40, 50, 60, 70, 175. And we can keep on going on and on for as long as we need to find some multiples of 35. Now with factors, it's slightly different, the process. We know that the factors are within 1 and 35, and we know that at least 2 factors of 35 will be 1 and itself, so we put those in. Now note, I leave a gap and I write 35 at the end. Okay, so this gap here is because the other factors, if there are any, will be within here if we were to write it in numerical order. So we'll look at 2 first of all. We start with 1, then we look at 2, then 3 and 4 and so on. So we look at 2. 2 is an even number and 35 is odd. So we know that 2 will not be a factor. So now we can look at 3. 10 times 3 is 30. So we carry them from there, 33, 36. So 3 is not a factor of 35. So we move on to 4. Again, 4 is an even number. It won't be 4. Let's go to 5. Well, if a number ends in 5 and 0, it does have 5 as a factor. So 5 will be 1. Now 5 has a pair because 5 times something gives me 35. What is that something? So you do the 5 times table until you get to 35. That will give you its partner. 5, 10, 15, 20, 25, 30, 35. That's 7. So 5 times 7 gives me 35. That means 5 is a factor and 7 is a factor. So I'll put that in here. And the only other number left between 5 and 7 is 6, which is an even number, and we know 6 doesn't go into 35. Therefore, these are the factors of 35. So just to remind, you start at one end and work towards the middle, start at the end and work towards the middle. Those are the way we look at finding factors. So now it's your turn. Have a go at finding the next 5 multiples of 12 and all the factors. So we have 12, 24, 36, 48, 60, and so on. So the factors are 1 and 12. 2 times 6 is 12. And 3 times 4 is 12. So you do them in pairs, and there are no other numbers between 3 and 4, so we know we've got all the factors. Okay, let's try another one. 15. Try and find the next 5 multiples of 15 and all its factors. Okay, so you should have 15, 30, 45, 60, 75, and it will continue from there. So the factors are 1 and 15. 1 times 15 is 15. 2 doesn't go into 15, so there won't be 2. So the next number we try is 3, and 3 times 5 is 15. And the only number in between is 4, and 4 doesn't go into 15, so we know we've got all the factors. Okay, and one more. See if you can find the next 5 multiples of 30 and all its factors. The multiples are 30, 60, 90, 120, 150, and so on. So there are a lot of factors here. 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. And 5 times 6 is 30. Thanks for watching. If you want to see more videos like this, make sure to subscribe to the channel and hit the notification bell. See you in the next video.